Hi listeners, welcome to the video lectures. I am Roopa R, Assistant Professor in Department of CSE Data Science, Madanapalle Institute of Technology and Science. Today I would like to give brief explanation about Introduction to Dynamic Programming. Uh, Here I would like to cover about introduction of an algorithm, optimal solution, dynamic programming, applications of dynamic programming, and one of the application 0 by 1 knapsack problem. So generally, if you take a computer to perform any task, programs are written. How the program is written means based on the algorithm. Initially, we develop the algorithm, and that algorithm is implemented using any programming language. What is an algorithm means it is a step-by-step process of doing any task. So if you take any algorithm has certain properties. Each algorithm may or may not take the input. After executing an algorithm, an output will be there. At least one output should be there, or more than output can be there. Every step in the algorithm should be unambiguous. Unambiguous means clear, and every algorithm should terminate after a certain amount of time, and each algorithm should be efficient in the sense it should take minimum amount of time to execute that algorithm. So that if you see the definition here, an algorithm is a sequence of unambiguous instructions for solving the problem, for obtaining the required output for any legitimate input in finite amount of time. So in computer, if any problem is given, what are the different paradigms that are used to solve means? There are five different approaches or paradigms are available. The first one is divide and conquer, dynamic programming, greedy approach, backtracking, and branch and bound. So if you see dynamic programming and the greedy technique, these two are used to find the optimal solution. Here we get the question of what is a optimal solution. Suppose if you take a problem, there will be n solutions. So among the n solutions, some solution may satisfy the condition given in the problem. Those solutions are called as a feasible solution. A feasible solution with the minimum or maximum output is called as a optimal solution. Let me take an example. Suppose a person wants to send amount to the another person. What are the different solutions for this problem means? A person can directly go and give amount to the second person, or a person can go bank and deposit amount in the second person account, or a person can use the net banking to send the amount, or a person can use the online apps like Google Pay, Phone Pay to send amount. So these are the various possible solutions. Suppose if person wants to send amount within the 10 minutes, then what are the feasible solutions means? Doing using the net banking or using the apps like Google Pay, Phone Pay, he can send amount to the second person. So that is the these two are called as a feasible solutions. Among these two feasible solution, which is the optimal solution means sending an amount through the phone pay or Google Pay is the optimal solution. Why it is the optimal solution means this solution takes the minimum amount of time to send amount to the another person. If you see another example is also given z equal to 3x plus 4 5. This is the expression. So here for this expression, what are the given input sets means 0 comma minus 1, 0 comma 0, 0 comma 1, 1 comma minus 1, 1 comma 0, 1 comma 1, 2 comma 2, 3 comma 3, minus 4 comma 4. All these are the given input sets x and y values. Among these values, we can say feasible solutions are 0 comma minus 1, 0 comma 0, 0 comma 1, 1 comma minus 1, 1 comma 0, 1 comma 1. Why these are feasible solution means in the given problem on the x and y they have given the conditions. So if you see x value, the x value will be should be less than 0. X value will be between the 0 to 1 and y value between the minus 1 to 1. So these conditions are satisfied by these feasible solutions. And what is the optimal solution means? The optimal solution is 1 comma 1. Why it is the 1 comma 1 is optimal solution means, in the problem itself they have given the objective function. What is the objective function means, whether a problem should get maximum output or minimum output. So that maximum or minimum we can call it as a objective function. So here objective function is maximum. So if you give the 1 comma 1 as the input, we are getting the maximum output. So that is called as a optimal solution. For any problem, there is only one optimal solution. Now come to the greedy approach. So what is the dynamic programming? So dynamic programming is used to solve the optimization problem. What is the optimization problems means? A problem with the optimized solution, we call it as a optimization problems. So this dynamic programming works on the principle of optimality. What is the principle of optimality means? So here we can see sequence of decisions are taken to get an optimal solution. Taking this sequence of decisions, we call it as a principle of optimality. Generally, how dynamic programming is working means, in 4 steps it works. What are the 4 steps means? It divides the complex problem into subproblems, and second step, for each subproblem it finds the optimal solution, and the third step, the for each subproblem whatever the optimal solution is there, that will be stored. If you see, the dynamic programming nature is similar to the divide and conquer. In divide and conquer also, the problem is divided into the subproblems. Again, the solutions of each subproblems are combined. That is the nature of the divide and conquer. Dynamic programming also, we are doing the same thing. The problem is divided into subproblems. But the thing is, in the dynamic programming, we are getting the overloaded subproblems. What is the overloaded subproblems means? The subproblems will be repeated more than one time. It is called as a overloaded subproblems. So here there may be chance of subproblems repetition. Instead of doing every time, what we'll do means, each subproblem solution is stored separately. So whenever it is repeated, instead of redoing that one, the solution of already calculated will be used as it is. So for that reason, subproblem solutions are stored. That is the third step. Coming to fourth step, based on the subproblem's optimal solution, finding the optimal solution for the given problem. So we'll let me take an example of Fibonacci series. What is the Fibonacci series means? In this series, the starting two terms are 0 and 1. The remaining terms are calculated as sum of previous two terms. For example, 0 and 1, the next term is calculated 0 plus 1, 1 will get, and the next term is 1 plus 1, 2. So next term is 1 plus 2, 3. Like that, sum of previous two terms. Like that, we'll find this series. If you see the recurrence relation of the Fibonacci series, this is the recurrence relation. If n value is 0 means the series value is 0. If n value is 1 means the series value is 1. If n value is greater than 1, how to calculate the value means Fibonacci of n minus 2 plus Fibonacci of n minus 1. So this is the sum of previous two terms. If you write the recursive algorithm for the Fibonacci series, this is the recursive algorithm. If n value is less than or equals to 1, then return the n value. Otherwise, return the Fibonacci of n minus 2 plus Fibonacci of n minus 1. So if we construct the tree for this recursive Fibonacci series, this is the tree representation of the Fibonacci series. Here, this Fibonacci 3, Fibonacci 4, Fibonacci 1, Fibonacci 2, all these are the subproblems. So initially I discussed a problem is divided into the subproblems. In the dynamic programming, there is a chance of getting the overloaded subproblems. What are the overloaded subproblems here means? If you look at here, Fibonacci 3, again it is repeating Fibonacci 3 here. If you see Fibonacci 1, Fibonacci 1, Fibonacci 1. So more than one time, all the subproblems are repeated here. So every time, instead of redoing or resolving that subproblems, what we'll do means, once optimal solution is found for the subproblems, those solutions are stored inside of the inside of the memory for the further use. So how to store the solutions means there are two ways we can store the solutions. Those two ways are memorization and tabulation. Memorization is called as a top down approach. So that means the previous example is the example for the top down approach. That means we'll start from the Fibonacci of 5 and we'll go to the bottom until Fibonacci 1 and we'll calculate the Fibonacci 1 value. This approach is called as a top down approach. So here used technique is memorization. One lookup table is used for this one. Initially, all the values are initialized with the -1, -1. When the subproblem is solved, then that value is stored here. Suppose Fibonacci of 0 is calculated, the -1 is updated to 0. Fibonacci 1 is calculated, the -1 is updated 1. Like that, when the entire, all the subproblems are completed, this table is filled with the optimal solutions 0, 1, 1, 2, 3, 5. So this process is called as a memorization. Separate lookup table is used. Initially, that lookup table is initialized with the -1 values. Once problems are solved, the optimal solution values are updated in the lookup table. Now come to the second approach. The second approach is called as a tabulation method. So if you see the Fibonacci series, the iterative approach is the example of the tabulation. The iterative approach is nothing but the non-recursive approach. So here array concept is used. If f of 0 value is 0 and f of 1 value is initialized with the 1, the remaining terms are calculated based on the previous two terms. F of I is calculated f of I minus 2 plus f of I minus 1. So here we are storing the result in the form of array. So this process is called as a tabulation method. So next, what are the different applications of dynamic programming means 0 by 1 knapsack problem, matrix chain multiplication, multi-stage graph, optimal binary search trees, all page shortest path problem, traveling salesperson problem, reliability design. All these are examples or we can say applications of dynamic programming. Here I'm going to discuss about one application, that is 0 by 1 knapsack problem. So what is a 0 by 1 knapsack problem means? So look at here, knapsack is nothing but the bag. A bag with some size is given. If you see in the figure, a bag with 15 kg is given. And there will be n items. Each item has weight and profit. So we can't keep all the items inside of the bag or knapsack. Only knapsack size is limited. We can keep only a limited number of items. Now here question comes, what items we have to keep inside of the bag? So for that reason, we are considering the items which are giving the maximum profit. So to solve this problem, we are using the dynamic programming concept. If you see in the problem itself, it is given as 0 by 1. What is the 0 by 1 means? Suppose we are keeping an item inside of the bag, then we'll mark that item value as a 1. So here the solution is the binary solution. For every item, one value is given. That value will be either 0 or 1. So if we are keeping that item inside of the bag, then the item value will be 1. If we are not keeping the item means that value will be 0. So in the dynamic programming, in two ways we can solve this problem, using set method and using table method. In this video, I'm going to cover about the table method. While filling the table, how to fill the table means this formula is used. So while with the example, I'll explain this formula. Let me take an example. Here, three items are given. First item weight is 1, and the second item weight is 2, and third item weight is 3. For each item, profits are also given. First item profit is 6, second item profit is 10, next item, third item profit is 12. If you see, knapsack size is 5. So because of knapsack size 5, we cannot keep all three items inside of the knapsack, because 1 plus 2 plus 3, the total size is 6 here. So we can keep only some items inside of the knapsack. So which items we have to keep means, here we have to construct the table. How to construct the table means, the maximum size here is 5. So 5 plus 1 columns. 5 plus 1 columns. The column should start with the 0, 1, 2, 3, 4. What is the maximum size? That should come last. And two extra columns we are taking. So these two extra columns are weight and values. And number of rows depends on the number of items. Here number of items are 3. So 3 plus 1, 4 rows we have to take. So initially 0th row and remaining rows are for the items. So item 1, item 2, item 3. Item 1 weight is 1, item 2 weight is 2, item 3 weight is 3. And if you see the item 1 profit 6, item 2 profit 10, item 3 profits are 12. Now coming to the 0th row. What is the 0th row means? We don't have any items. If we don't have items means, we cannot keep inside of any of the bag. Here the column indicates the bag size. For example, 0 means we don't have bag. If we don't have bag means we can't able to keep any items. So complete this column is filled with the zeros. Okay. And 1 indicates the bag size is 1 kg, and 2 indicates the bag size is 2 kg. Like that, 5 indicates the bag size is 5 kg. So if we don't have items means, in any bag size we can't able to keep any item. So the first row is entirely filled with the zeros. Similarly, if we don't have any bag means, we are unable to keep the items. So first column is also filled with the zeros. Now coming to the here, how the table is filled means, row by row we have to fill. Now 0th row is completed, go to the first row. So one first row means we have only item 1. So item 1, if you see the column 1. So what is the meaning of 1 comma 1? So here I am writing 1 comma 1 means, 1 comma 1 means uh, I have one item and the bag size is 1 kg. If you see the item 1 weight 1 kg, so I can keep inside of this 1 kg bag. If I keep that item inside of 1 kg bag, how much profit I am earning here means 6. So here I am filling this value is 6. You can look at here in the below table, 1 comma row 1, column 1, row 1 column 1 value is 6. Okay, and similarly row 1 column 2. What is the meaning? Row 1 column 2 means I have a bag with 2 kg capacity and item with 1 kg. I can easily keep a 1 kg item inside of a 2 kg bag, so that I am earning the profit of 6. See, row 1, up to row 1 I have only one item, that may be any size bag, or one item is 1 kg. So in all I can keep only one item. So this entire first row is filled with the profit of first item. What is the profit of first item? 6. If you see the below table, the entire first row is filled with the 6. Because I have only one item, that item weight is 1 kg, that may be any kg bag, I can keep that item, so that I am earning the profit of 6. Now come to the second row. In the second row, 2 comma 1 entry. What is the second row means? I have two items. Item 1 is there, item 2 is there. So if you take the entry of 2 comma 1, what is the 2 comma 1 means? I have two items, but my bag size is only 1. So 1 kg. My bag size is only 1 kg. So item 2 size is 2 kg. I cannot able to keep 2 kg weight inside of 1 kg bag, but I can keep first item which is of 1 kg. So if you see the 2 comma 1 entry, it is filled with the 6. Why? Because I am keeping inside of the bag item 1, so that I have earned the profit of 6. If you see the 2 comma 2 entry, what is the 2 comma 2 entry means? So here I have two items. Item 1 is there, item 2 is there, and the bag size is also 2 kg. Here I have two options are there. What are the two options? Not two options, three options are there. What are the three options means? I can keep item 1 alone, or I can keep item 2 alone, or I can keep. So if you see the item 1 weight 1 kg, item 2 weight is 2 kg. So I cannot keep both because the bag size is only 2 kg. I can keep either item 1 or item 2. Item 1 is giving the profit of 6, item 2 is giving profit of 10. Among these two, which is the maximum means 10 is the maximum. So I'll keep the item 2 instead of item 1. So that's why if you see the 2 comma 2 entry, here it is filled as a tin. So how this 6 comma 10 comma 0 is applied means, for this I'm using the formula, this one, d of I minus 1 comma w. Here d of I minus 1 w means we have to refer the table entry. If you take the pair 2 comma 2 means, so here I value, first value is 2 and w value, first value is I and second value is w. 2 comma 2 means I value is 2 and w value is also 2. So 2 comma minus 1 means 1 and w means 2. We need to refer the 1 comma 2 entry. So in the second table here I am referring the 1 comma 2 entry. 1 comma 2 entry is 6. And similarly, and the second part, if you see, the second part is 2 comma 1. I value is 2. 2 comma 2 we are calculating. No? So 2 minus 1 means 1. W minus weight of I. W means 2 value minus weight of I. The second item value. What is the second item weight is 2. 2 minus 2 means 0. So this entry is nothing but the 1 comma 0 plus value of I. What is the value of I? I value is 2. So value of 2. That means profit of second item. So that formula is calculated here. So you can look at here, the first value is 1 comma 2 value. 1 comma 2 value is 6. 6 comma. Second value is 1 comma 0 plus 1 comma 0 is 0 entry. If you see 1 comma 0, the value is 0. So 0. And the value of second item is 10. So 10 plus 0, 10. Maximum of 6 comma 10 is 10. Like that, formula based, you can go for formula based filling, or you can also go for the logical thinking. You can go, for example, 2 comma 3. What is the 2 comma 3? My bag size is 3 and I have two items. Here also three possibilities, keeping the item 1 alone or item 2 alone, both item 1 and item 2. Suppose if I keep item 1 alone, I'll get the profit of 6. If I keep the item 2 alone, I'll get the profit of 10. Suppose if I keep both items, because item 1 weight is 1, item 2 weight is 2, 1 plus 2 will get the 3 kg. So in the 3 kg bag, I can keep 3. So 1 plus 2. So item 1 profit is 6, item 2 profit is 10, 6 plus 10, I'll get 16. Similarly, if you go for the 2 comma 3 entry 16, 2 comma 4. If you see the 2 comma 4, what is the meaning? My bag size is 4 kg, but I have only two items. So two items together is 3 kg. So that maximum profit here I am earning is 16. And 2 comma 5, bag size is 5, but I have only two items. I can put together, I'll add only 16 is the profit. Now go to the third row. In the third row, 3 comma 1. Take the first entry, 3 comma 1. What is the 3 comma 1 means? I have three items, but my bag size is only 1 kg. So here I can keep only item 1 alone, because item 1 weight is only 1 kg. So if I keep that item 1, I'm getting the profit of 6. So that's why 3 comma 1 is filled with this 6. If you take 3 comma 2, so 3 comma 2, what is the meaning? My bag size is 2 kg. I can keep either item 1 or item 2. If I keep item 1, I'm getting only 6 profit. If I keep item 2, I'm getting 10 profit. So I'll keep 10. So this is called as a principle of optimality. If you see 3 comma 3 entry. 3 comma 3 entry, what is the meaning? My bag size is 3 kg. I have 3 items, item 1, item 2, item 3. So if you see what are the possible combinations here, item 1 I can keep, item 2 alone I can keep, item 3 alone I can keep, or combination of item 1, item 2. So in this 3 comma 3 entry, I have four choices. Among the four choices, based on the profit, I am choosing one solution. This is called as a principle of optimality, taking the decisions to find a optimal solution. So if you see one comma item 1 is giving the profit of 6, item 2 is giving the profit of 10, item 3 is giving the profit of 12. But item 1 and item 2 combination, if you take one more combination, item 1 and item 2, so 6 plus 10, it is giving the 16. So here 3 comma 3 entry is filled with the 16 instead of item 3. Similarly 3 comma 4, if you go for the 3 comma 4 entry, so here again we have 5 options. What are the 5 options? Item 1 alone, item 2 alone, item 3 alone, or item 1 and item 2 combination, or item 1 and item 3 combinations. We can go for this 5 combinations. Among 5 combinations, item 1 and item 3 is giving the more profit. So here item 1 weight profit is 6, item 3 profit is 12. So 6 plus 12, 18. So this bag is filled with the 18. And if you see the 3 comma 5 combination, so here in 3 comma 5 combination, we'll get the 5 combinations. What are the 5 combination? Means I can keep item 1 alone, or item 2 alone, or item 3 alone, or combination of item 1 and item 2, or combination of item 1, item 3, or combination of item 2, item 3. So if you see item 2 is profit of 10 and item 3 is profit of 12. So 10 plus 12, it is giving the profit of 22. So among the all the combination, this combination is giving the more profit. So this 3 comma 5 entry is filled with the 22. Like this, logically you can think and you can place the values, or you can follow the formula to fill this table. Why this paradigm is named as a dynamic means dynamically we are calculating the values, optimal solutions we are finding. So that's why it is named as a dynamic programming. So if you see the end of the problem, for all the items we have to provide the binary solution. That is, whether we are keeping that item inside of the bag means we'll mark that item value as a 1. Otherwise we mark that item value as a 0. Suppose if logically you are filling this table means go to the last entry, last cell. 22 is the maximum profit that we can earn in this problem. So this 22 how we are achieving means the combination of item 2 and item 3. So for item 2 will mark as a 1 and item 3 is also marked as a 1. But we are not considering the item 1, so this one is marked as a 0. So logically, if you are filling the table, then we can go for this approach. Suppose using the formula you are filling the table means, then how to fill this binary solution means take the last cell value. What is the last cell value is here 22. Check whether 22 is previous row. 22 is there in the previous row. Suppose if it is previous row, it is there means we'll mark item 3 value as 0, because last row only we are getting the maximum profit, but that profit already we are earning in the previous row means this item 3 is marked as 0. If previous row it is not there means then item 3 will be marked as 1. Okay, if you see item 3 marked as 1, and what is the maximum size, knapsack size here 5. 5 minus item 3 weight is 3. 5 minus 3 means still we have 2 kg. 2 kg leftover is there in the knapsack. So we'll go to the previous row. What is the previous row maximum size? 16. Check whether 16 is there in this row, second row alone, or previously 16 is there. If previously it is there means we'll mark W2 value as 0 and we'll go to the wherever it is starting point, there only we'll mark as 1. So here only second row 16 is there, so W2 will be marked as 1. And if you see the knapsack, the leftover size is 2, the item 2 size is 2, 2 minus 2, entire knapsack is completed. So for weight 1 will mark as a 0. Like this, if you fill the table using the formula, this approach will provide the binary solution. In the dynamic programming, uh, we can always, maximum times we can find the optimal solution very easily. But the problem with the dynamic programming is we need to construct the all possible solutions, and for every solution we are storing the result. Some memory wastage is possible in the dynamic programming. So this is about the dynamic programming. I hope you understood what is the dynamic programming concept. I would like to thank the management, principal, and head of the department for giving this wonderful opportunity. Thank you.